Alright, unit circle. Obvious things to consider. Stop using degrees, minutes, and seconds. Start using radians. And there are 2 pi radians in a circle. It is called a unit circle because the radius is 1 unit wherever you touch the outer point of the circle. Yeah, so let's draw a unit circle. So this is the point 1, 0, and this is going to be the point 0, 1, and obviously the other points are going to have their respective signs switched. This is my very good circle, as you can tell. I am the best writer on the planet. So the only things we need to do is basically remember the first quadrant. For now, if this is a basic introductory video, I'm sorry if you wanted something a little more advanced. This is just the bare bones. If you just want to know the bare bones straight away, like no questions asked, let's just find out the information. Let's not go through the crap. So this is an angle of 0 or 2 pi. So 2 pi if you go around the circle once, because the reason why the circumference, this angle here is 2 pi is because the circumference formula of a circle, if you recall, is 2 pi radians. But remember that our radius is the value 1, which means that c is just equal to 2 pi, which means that's why how we get this angle. Alright, so in a unit circle there's 3 angles in the first quadrant that we care about. The first one here, this angle here, I'll just draw the triangle here. I'll draw a small little accurate representation of it. This angle right here is pi over 6. I'm sorry if you can't see my pi. And that's pi over 6. And the value of the coordinate for the y at pi over 6 is 1/2. And the x coordinate for the angle of pi over 6 is √3 over 2. Now, let's go to this triangle. And its angle is pi over 4. Now, the x coordinate of pi over 4 is √2 over 2. And likewise, the y coordinate is also √2 over 2. Which is pretty awesome. So this is 45 degrees, by the way. So this is 30 degrees. But basically, when you first start learning unit circles, you still need to deal with degrees, because we've been taught degrees all our life, so we don't know any better. So use the degrees as a guide for as long as you can, but try and shift your skill to knowing what pi over 4 is without having to think, oh, that's 45 degrees, and just using degrees all the time in your head. Just try and make the idea of pi somehow being an angle second nature to you. That's the key. Now for this really tall triangle, that's not a very good triangle. The angle is pi over 3. And then that means the value of the y in pi over 3 is √3 over 2. And the cosine, the x coordinate is 1/2. So that makes sense, right? Was when you think about it, if you look back to the unit circle, the higher the angle, it's going to be closer and closer. Like, you see this line? It's sort of shifting up the curvature of the circle. It shifts up the curvature of the circle towards the angle of pi over 2. And at the angle of pi over 2, y is 1. So when we have a sharp angle like pi over 3, by the way, pi over 3 is 60 degrees. So when we have an angle like pi over 3, when you think about it, of course the x, like the value of x is going to be smaller, because we're getting closer and closer to the value of 1 for y, which means that x has to end up getting to 0 some time or another. And if you've noticed something really cool, like we already think that it's awesome that the angle of pi over 4 has x and y values the exact same. But let's look at the angle of pi over 6. The y values are half, right? Well, the value of x is 1/2 for 60 degrees, or pi over 3. So you only need to remember one of these. Pick the one that you want to remember, and then realize that like for me, I remembered that pi over 6, that the y values are half. So I immediately remembered that for pi over 3, the x values are half because they switch. And these ones switch too. Anyway, that's all you need to know to start off with. You just need to know that the angles pi over 6, pi over 4, pi over 3, and these values of the specific coordinates. And that's pretty much the gist of it. Oh yeah, one more thing. I remember when I was in school, I'm still in school, I'm in university, but when I was learning about this for the first time, I remember I'd learnt about bearings first, and the angles went clockwise. I don't know if you guys had that experience, but remember at this point here it was like 0, and this was 90, 180, 270, 360 degrees. Well, in the unit circle, it's actually the other way around. So we're going around the circle anti-clockwise or counterclockwise. So that's a little bit of a change that you're going to have to try and get used to. So we're counting angles this way, and that is the positive convention. Because if you've noticed, if you were in class and the teacher said something like, just said, oh, you just need to know the cosine of negative theta. Or they're showing you formulas from a book, and they're showing you this formula, the cosine of negative theta is the cosine of theta. Remember how I just told you that the positive sign convention for the unit circle is going around the circle counterclockwise? If you're writing the negative of an angle, that's assuming you're going the other way, which means you're going clockwise. And one last thing before I close off the video. This quadrant is C, this quadrant is A, this quadrant is S, this quadrant is T. C stands for cosine, A stands for all, S stands for sine, T stands for tangent. So basically, the cosine, that's why the angle in here is positive. Because if we're going around the other way, the cosine of negative theta, we're going around this way, around the circle. But remember, the cosine of the negative angle is actually positive in this quadrant. And I'll explain that in the next video. But just for now, remember the acronym CAST, or CAST. How easy is that? And you just need to remember where it starts, so CAST. It also goes around the unit circle counterclockwise, so it kind of also fits the sign convention, which is pretty handy. Anyway, that's the end of the video, so I hope that helps just a little bit.